Hello guys, myself Emily. So now I'm going to discuss about MPM, model problem mapping. So the template we can just classify the template first. First we will write the given values of a question, and next to find.
Can you explain what is a model problem mapping, MPM?
Sir, if we take a problem, we should part it out. We should take all the subdivisions inside that problem. We should read the question twice, and we will just divide it into this 4. So it's very easy when we take and revise it.
So when you look at the problem, you have to list out the given parameters first, and that should be symbolically represented, and that can be done based on the units given in the problem itself. When you carefully go through the problem, you can easily identify the symbolic expression also. For example, 100 ohms, immediately you can say it is R. 220 volt, immediately you can state it is voltage, that is V. And when the parameter is given in hertz, means you know very well it's frequency, so 50 hertz. Okay, so first you have to list out the given parameters, and then what are the parameters to be found out. So what is to be found out? So that should be mentioned. So to find. So in the first question, now we are discussing the alternating current exercise problems. That is the first problem, in which they have given the RVF, and they have asked IRMS. What is IRMS?
This root means square of current.
Root means square current, square value of current. And what is power? I mean net power. That is P net means net power. Is it not right? And what is the concept? You should be able to identify. That is root means square and power. And you have to list out the formula also accordingly. Okay. And what are the formula, related formula here? IRMS is equal to IM divided by root 2, and then
power net power is equal to I square R.
Okay, then
and V is equal to IR. Here we don't know the IM, sir.
Okay.
There is not I given. So we should find the I first.
What is that? V is equal to IR?
It's Ohm's
Ohm's law. So from the Ohm's law we can find out the I, and where from you can get the value also. Okay, right. So that is with regard to the first problem. So if you go on classifying all these things based on the concept, and that is template is called model problem mapping. Okay, right. So you can proceed.
Shall I go on to the second question or first?
Yeah, you can proceed with the second question.
First I'll read the question. First subdivision is the peak voltage of an AC supply is 300 volts. So the first given value is voltage, and that is 300 volt. What is the RMS of the voltage? So RMS of the current means IRMS, and RMS of the voltage.
So it is given as a peak voltage.
Peak voltage.
Peak voltage, either it can be represented by V0 or VM. VM. You can mention that VM. Right. Then
the RMS value of a current in an AC circuit is 10 ampere. What is the peak current? So it is vice versa in the second subdivision. They have given IRMS, that is 10 ampere, and they are asking what is the I maximum. So we have classified to find and the given. Next is the concept. Here also the root mean square concept and maximum current concept. That also we are going to derive it from the IRMS formula. So for the first subdivision, VRMS is equal to VM by root 2. If we apply the given value in this formula, we can easily get the value. And for IRMS, we need to derive the formula for IM from this value itself. So IRMS is equal to IM by root 2 gives IM is equal to IRMS into root 2. So it will be clear, sir. If we just substitute it, we can get the answer.
okay.
For the third question, and 44 millihenry inductor is connected to a 220 volt 50 hertz AC supply. Determine the RMS value of the current in the circuit. So they have given the inductance.
How do you know it is inductance?
Sir, Henry is the unit
Henry is a unit of inductance.
So here milli represents 10 to the power minus 3.
So millihenry means 10 power minus 3 Henry. Okay.
and voltage they have given, so 220 volts, frequency is 550 hertz.
Okay.
So they have asked the IRMS value. We know it is the root mean square concept, and IRMS is equal to Im by root 2. So we have more questions in root mean square concept itself. Fourth question, a 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. Determine the RMS value of the current in the circuit. They asked the same as the third question itself, but here they have given the capacitance, that is 60 microfarad, that is nothing but 10 to the power minus 6. Voltage is 100 volts and frequency is 60 hertz. Here they asked us to find IRMS value, that is nothing but the root mean square concept, and IRMS is equal to Im by root 2.
And how do you find out Im?
Sir, Im can be taken in IRMS formula itself.
No, it is given as capacitance. Okay. Is it not?
Sir, it is the energy stored in the...
No, that is you have got only capacitance other formula, and how you can find out? Take down IV is equal to, no, write down under the formula IV is equal to EV by XC. Is it not? Okay. So it means what? That is I is the current, E is the voltage, X is the capacitance. I mean reactance, capacitive reactance. Okay. Right, proceed.
Sir, for the fifth question, it is based on the previous two questions. In the exercise 7.3 and 7.4, what is the net power absorbed by each circuit over a complete cycle? Explain your answer. So here the given is based on question 3 and 4 we should take, that is nothing but the IRMS value and root mean square. Both the questions are the common given concept, sir. To find is the IRMS, root mean square is the concept, and IRMS formula. Here we need to just explain about the current over a complete cycle and the voltage over a complete cycle, which leads and which lags by the phi. It is a theoretical question, sir. And sixth one, a charged 30 microfarad capacitor is connected to a 27 millihenry inductor. What is the angular frequency of free oscillations of the circuit? This you have taken in the previous class. It is LC oscillations, and the given is capacitance is 30 microfarad, that is nothing but 30 into 10 to the power minus 6. And inductance is 27 millihenry, that is 27 into 10 to the power minus 3. And to find is omega naught is also can be called as the oscillation, that is a symbol that is represented, sir. And the concept is LC oscillation. They are given the L and C. Omega naught is equal to 1 by the whole root of LC is the formula. And some question, a series LCR circuit with R is equal to 20 ohm, L is equal
Omega R is called oscillation, that is a resonance frequency. Resonant frequency. Then
the series LCR circuit.
And how do you give that unit resonant frequency omega naught? That is given as theta by t. Omega is equal to theta by t. So it can be called what? Radian per second. So the unit is, take down to find under the
omega
unit radian per second, rad, RAD per second. That's it. Now you can put simply S, small s. Okay, proceed.
For the seventh question, they have given the resistance is equal to 20 ohms, inductance is equal to 1.5 Henry, and capacitance is 35 microfarad, voltage is 200 volts, and yet they have given the condition XL is equal to XC. That is nothing but the inductive reactance is equal to the capacitive reactance. They have asked us to find what is the average power transferred to the circuit in one complete cycle. So P average is equal to, we want to find, and the concept is LCR series concept. XL is equal to L omega and XC is equal to 1 by omega C.
Okay.
P average formula is I into V.
Okay.
Eighth question. Show a series LCR circuit connected to a variable frequency 330 volt source. L is equal to 5.0 Henry, capacitance is equal to 80 microfarad and resistance is equal to 40 ohms. For the first subdivision, we need to find omega R, that is resonant frequency, and I naught is equal to, we need to find the peak current. And for the second subdivision, we need to find the impedance. Third subdivision, we have to find the VRMS across the LCR. So here the concept is, for first one it is resonant frequency. For the second one it is the impedance concept, and the third one it is the root mean square concept.
Okay.
Formulas for the first one, omega R is equal to 1 by the whole root of LC, and for the second one Z is equal to R square plus XL minus XC the whole square. Here they have given the condition that is XL is equal to XC, so it is obviously 0, and the square root of R and the root will get cancelled, and impedance is equal to only R.
Very good.
And the maximum current is equal to root 2 of I, and the VRMS is equal to Vm by root 2.
Very good. So how do you feel this kind of approach, that is model problem mapping, to solve the exercise problems?
If we note it down in a paper and if we just started solving, it can be easily in one go.
So only thing is, it is also useful for
exam time,
just to review and recap during the exam time. It will be very useful for you. And not only that, that is here you have got all clues. Only thing is, you have to work out the arithmetic part. Except that everything is given at one stage. So this can be treated as a sketch note or a cheat sheet to solve the exercise problems. And for each chapter, you can develop such practice, especially in physics and chemistry. It is also applicable in maths. Okay, right, very good, thank you.